Welcome to another video from the Setup Guide series for the Mira Encrypted Traffic Orchestrator, also known as the ETO. In this video, we'll explore how ETO enhances your network security, particularly in the realm of TLS traffic and certificates, working as a firewall at the SSL and PKI level. ETO is not a substitute for your NGFW or IPS or even IDS. Rather, it complements them. It acts as a must-have important layer of defense, a float and decryption task related to SSL, TLS, and SSH traffic. To illustrate, let's look how the ETO works in practice. We configure a policy set to universal decrypt in inline passive mode. In this mode, ETO sets in front of your IDS, decrypting incoming traffic before sending a copy to the IDS. Then traffic gets re-encrypted and sent to its destination. For our demo today, we're using badssl.com website to test various types of pages against our ETO policies. With an ETO policy setting, we can determine how it handles SSL TLS traffic via SSL TLS version actions. Actions can be specified for when the ETO is decrypting and non-decrypting. This includes version ranging from SSL 3.0 and TLS 1.3. By default, ETO rejects SSL 3.0 and TLS 1.0 due to vulnerabilities in these old protocols. However, you can choose to allow TLS 1.0 traffic for legacy network with the ETO decrypting the traffic so that your security tools can detect threats. Simply adjust the setting, save, and then activate the change on the segments page. As we test a TLS 1.0 page on badssl.com, we can access it successfully. ETO session logs show that the action is resigned, indicating that the ETO allows decrypts and forwards a copy of the traffic to the attached appliance. And if we go back to our ETO policies, we can change the SSL TLS action to reject. Again, we will need to save and activate the change on the ETO segments page. And as you can see now, revisiting the same TLS 1.0 test page on badssl.com, we won't be able to access the page this time. ETO session logs now display the action as reject, signifying that the connection was terminated at the ETO. This prevents other security tools from wasting resources on it. Another thing we can do in the ETO's policy section is that we can allow, drop, or reject traffic based on the status or properties of the server certificate under certificate status actions. We can, for example, set the ETO when the policy is set to decrypt to reject all traffic using self-signed certificate. Then we'll need to save our change and activate the segment again. We'll test the self-signed page at badssl.com, and we'll find that the page is inaccessible, thanks to the ETO actively rejecting it. Finally, implementing Mira's ETO alongside your active or passive security tools creates a defense in-depth strategy, providing multiple layers of security. ETO's specialized TLS traffic and certificate handling adds an extra layer of protection, reducing the workload on primary security tools and enhancing overall network security. Thank you for watching this demo. For any other guide videos, please check out our channel page.